Hi everyone, welcome to Friday's Discovery session. I'm Natalie Irwin here, Director of Stakeholder Engagement here at Efficiency Canada. Just a reminder, if you're joining us for the first time, we have our presenters here present for approximately 20 minutes, and then we're going to open the floor to questions after that for another 20 minutes. So we ask you to hold your questions at the end. There are two ways to ask questions. One is you can raise your hand and I can unmute you, and you can ask your question yourself. The second way is you can go to the bottom of your Zoom screen and type in your question there, and I can essentially read your question out loud on your behalf. So we do have a firm stop at 12:45 Eastern time, so you can get back to your day or starting your day, depending where you are in Canada. So without further ado, I'd like to welcome our speakers who are joining us from beautiful BC today. From FortisBC, actually, we have Mila Barber, who's Program Specialist, Innovative Technologies, and Rav Dial, Energy Utilization Manager, again with FortisBC. So they're going to talk about the next generation of gas heating. So natural gas heat pumps have efficiencies that exceed traditional 100% barrier and offer pathways to reduce greenhouse gas emissions and mitigate electricity grid constraints. So let's take a stroll with FortisBC here with this beautiful picture they have to start us off and make us all jealous. Now all the rest of Canada that's covered in snow right now. So thanks for joining us, Mila and Rav, and I look forward to your presentation.
Thank you. So I'm excited to be here and to say that there has been breakthroughs with technology that now allows us to heat our homes and businesses with natural gas at over 100% efficiencies. And with natural gas heat pumps, we will have the ability to substantially reduce greenhouse gas emissions across North America and specifically across Canadian residential and commercial sectors. So thank you for the kind introduction, Natalie. My name's Mila Barber, and I'm a program specialist on FortisBC's Conservation and Energy Management team. FortisBC, we're a combined natural gas and electric utility servicing just approximately 1.1 million customers in British Columbia, Canada. And today I'm joined with my colleague, Mr. Rav Dial, and together we're going to talk about gas heat pumps and why they're the future of natural gas heating. And next slide, please, Rav. All right, so for today's presentation, I really just want to paint a picture of the current landscape of natural gas heating and really talk about the key factors that is driving the advancement of this technology category and really taking a look at where we are today with our natural gas heating and really where we want to be tomorrow and how we can achieve our future climate action targets. Then I'm going to pass it off to Rav, who's going to talk about key insights and technology performance, going over our gas heat pump pilot results. And then I'll close off the presentation today with an opportunity for folks on the line to support the evaluation and adoption of gas heat pump technology. Next slide, please, Rav. All right, so what are the key factors really driving the advancement of natural gas heat pumps? Well, here in Canada, our federal government, they have established the Pan-Canadian framework. So they have set aspirational goals for all space and water heating equipment for both the residential and commercial sectors to perform 100% efficiencies by the year 2035. So if we take a look at our home now, we've got our furnace, we've got boiler, we've got water tanks, but those efficiencies at best of what we see commercially available could be at the 95% mark efficiencies, maybe a little bit higher. So what does that mean for the future of our rebate programs and the future of what's going to be allowed to be installed in our homes? Well, we know that heat pump technology is going to be key in reaching that tier and reaching that Pan-Canadian framework to having efficiencies greater than 100%. And technology availability. Not a lot of people know about natural gas heat pumps. They're very aware of electric heat pumps, but never seen or heard a natural gas one. Today, there is zero technology commercially available for the residential sector. There are few technologies that have been around and are viable and available in the commercial sector. But we're really, joining forces with industry and manufacturers to really see how we can move the needle and get technologies to fill in information gaps and efficiency needs for these different sectors with a variety of end uses. And lastly, a key factor for FortisBC is we have a 30 by 30 goal, which aims to reduce our customers' emissions by 30% by the year 2030. Energy efficiency is a key factor to achieving that goal. And we see that gas heat pumps is going to really drive that for our customers to achieve that goal. There are definitely other pathways to reducing emissions, especially with renewable natural gas, liquefied natural gas, carbon capture, hydrogen injection. There's a lot of amazing things. So this is just one of the many pathways that we're going to be pursuing to reduce emissions across our territory. Next slide, please, Raf. All right, looking at this gas heat pump timeline. So currently, there are no utilities with full incentive programs for gas heat pumps. There's actually one in Canada that's put out a preliminary commercial gas heat pump offer, which is extremely promising. But it's not where it needs to be. So with forming industry collaboration groups, conducting pilot projects, and generating awareness on the technology performance, we believe that by launching a program incentivizing this technology within the next year, that by 2030, we'll be able to meet our 30 by 30 goals. And by 2035, we could have widespread adoption of gas heat pumps and really achieve that pan-Canadian framework. So the importance of this slide is we really need to start assessing the various categories of natural gas heat pumps now to inform the future, ensure that there's a viable path forward in achieving our climate action targets. Next slide, please, Rav. All right. Commonly asked questions that I get is, Mila, what is a gas heat pump? How is it different than an electric heat pump? How does it get efficiencies over 100%? That makes no sense to me. So gas absorption heat pumps, as you can see, this is an air source cycle, are very similar to electric heat pumps because they both extract heat from the ambient exterior air. But instead of using electricity, the GAP units combust natural gas to drive the compressor cycle and transfer heat from the exterior air into buildings. So although gas heat pumps tend to have lower operating efficiencies compared to electric heat pumps, they keep operating costs low by avoiding the switch to more expensive energy source. And what we're seeing is that they could potentially save anywhere from 30 to 50% energy savings for natural gas customers. What is also very attractive about gas heat pumps is that they operate really well in cold climates, maintaining very good efficiencies, which Rav will outline when he goes over our pilot results. All right, next slide, please, Rav. Okay, looking at kind of the technology landscape, we're seeing a great push in technology manufacturers from all over the world, such as Europe, Asia, United States, coming to Canada with their technologies. I believe when we first started assessing this technology category in 2016, maybe like 8 technologies were on our radar, but now there's over a dozen technology manufacturers. A lot of are in either the prototype stage or they're commercialized elsewhere, and they want to be brought to Canada to meet our specific codes and standards and requirements and our climate zones as well. So they're really seeking support from industry to help build that business case to get their technologies here to help us reach our climate action goals. So really, when we first started to assess this technology category, we had a lot of information gaps. We didn't know the energy savings, we didn't know the performance and maintenance, the awareness and customer acceptance, and what the affordability would be to install and maintain these. So, but really through conducting a technology market assessment, then evaluating gas heat pumps in the field, we have proven to fill in some of these information gaps and really identify the success in performance, customer acceptance, and little to no installation issues. So I'm now going to pass it off to Rav, and he's going to talk about our gas absorption heat pump pilot and really key learnings that FortisBC is going to use in, you know, when we're coming to launch a program incorporating these key insights. So take it away, Rav.
Thanks, Mia. A great segue, I guess. Exactly. When we first designed our pilot, it was early 2019, and in Canada, there was only one other installation that we'd heard of, and that was in Toronto. And they installed these Rober GAP units. I'm calling them GAP because gas absorption heat pump, GAHP, just so we're all on the same page. So there's one, well, in Toronto, they had one installation with 2 units installed, but we also wanted to demonstrate the technology in our own backyard or our own territory here in lower mainland of BC. Our climate zone here is climate zone 4, so we're a little bit more milder, as you saw on the first slide there. We don't have snow outside right now, so we're pretty warm. We're very happy with our weather. So which means it's usually less than 3,000 heating degree days for us. And our design temperature here in Vancouver is -7 degrees Celsius. So we developed a pilot to serve the domestic hot water needs in 7 commercial buildings. 5 were multi-unit residential buildings, ranging from 4 stories all the way up to 30, and 2 secondary schools. And these schools had teaching kitchens, so we thought it would be a really good domestic hot water load. And they were all across the lower mainland of BC, which is the Vancouver area here. Each site had 2 Rober GAP A units installed. These have a rated capacity of 36 kilowatts or 120 MBH. And Rober is manufactured in Italy, and they're originally from Italy, but they also have a distribution center in Evansville, Indiana, in the US. So it's commercially available across North America. When we looked at our pilot for the domestic hot water side, we decided 2 of these units per site, along with the existing backup boiler. And the backup boiler was used to just top up the load when required by the system, just in case the Rober units weren't able to keep up with the load. Our overall objective was to offer a rebate program to drive commercialization here in BC. And for that, we need to analyze energy savings, installation issues, and customer acceptance. Here's some before and after installation pictures. We had our implementation contractor engineer and design the system for each site. As you see in the first picture on the top left, that's existing domestic hot water boiler. As you can see, it's old, it's near end of life. You can see some rust on there. And the efficiencies on the boiler is 80%. That's a nameplate value. But they were found operating much lower than that. Okay, so we did 7 sites. All but 2 sites had 2 existing domestic hot water boilers. The other 2 just had 1 domestic hot boiler each. And they all range from size from 400 MBH all the way up to 750 MBH. The bottom right photo shows the GAP units. The units are 33 inches by 48 inches and about 50 inches high, and require clearance of 24 inches away from an existing wall, 31 inches in front for maintenance and access to the controls, and 18 inches between units. Each unit weighs 800 pounds as well. As you can see in the picture, this is prior to our installation of insulation. So we did insulate the pipes afterwards, but this is just a photo that we took. And for this project, the gap units produced hot water in the region of 50 to 53 degrees Celsius. And for the ambient operating temperatures ranging from -10 degrees Celsius to +25 degrees Celsius. So out of the 7 sites, we had to crane them on into 6 of the sites. They're just a bit too big to go through a standard doorway. And one of the sites we had installed on the ground level just outside the boiler room. As you can see on the bottom left here, on the bottom left, we created a prefabricated package or a skid package. These units, the gap units, are made to be located outside. Our pilot was focused on the domestic hot water side again, and due to these 2 factors in our Canadian plumbing code, we require glycol in the system. And with glycol mixture, we also require a double wall heat exchanger due to being potable water. To keep the sites consistent, so all 7 sites, we contracted and engineered and manufactured a skid package, which consisted of a double wall heat exchanger. You could kind of see it in the background there. 2 smart Danfoss smart pumps, as well as a glycol feeding station, as well as 80-gallon storage tank. And this is all mounted on a 6-inch high steel base frame for ease of transportation. We wanted to keep our sites consistent, so all 7 sites, so we had this installed on all of them. So energy savings, I know Mila touched on this before, but now we'll get into the great results that we found. So we found the COP, or coefficient of performance, to be 1.14 for our pilot. So this is above 100% efficiency. Very happy with this. We also measured the gas utilization efficiency of the unit, and we got 1.21. And I know not too many people are familiar with the GUE, which is the ratio of the energy a gas heat pump supplies to the energy consumed by the burner. And it's a gas basis only and based on the lower heating value. And in terms of natural gas savings, we saw 21% natural gas savings on the domestic hot water side for all the buildings. So some of the key learnings, I know I'm going through this very quickly, but we're always happy to answer any questions at the end. So one of the key things is domestic hot water load profile and right sizing. It's very important to right size the system. We'd initially decided on 2 units for each site and wanted the gap units to cover 70-75% of the existing load. We use the nameplate data of the existing boilers to estimate the building domestic hot water load, and which was incorrect. I think, as we know, engineers love to oversize systems, and the existing systems were indeed oversized. So it's very important to do a load profile. I'd suggest at least a month prior to installation, just see how much domestic hot water load they actually use. As we are aware, it's very important again to right size the system because the gap units show higher efficiencies when they carry most of the load. You want them to run constantly and as long as you can. Avoid short cycling of the gap units. A good fit is constant loads such as pools or space heating. As I've mentioned a few times, we focus on the domestic hot water side, but we are shifting one of our sites to the space heating, and we will have results later on this year. Another key finding is return temperatures. So just similar to condensing boilers, the return temperature, or the delta T between the supply and return of the units, gap units, is very important. You do have to maintain that control. And to optimize efficiencies, we do require the delta T to be greater than 2 degrees Celsius. So just like condensing boilers, there's a lot of learnings, especially when condensing boilers first came out. A lot of people didn't, a lot of the installers didn't know how to get those boilers operating in that condensing mode, just because a lot of the times the return and supply temperatures aren't optimized. So there's minimum delta T that you require to get into that condensing phase. And same thing with gap units. Another one is outside air temperatures. As we know, on heat pumps, especially on electric heat pumps, the colder the outside air, the lower the efficiencies. Well, with our pilot, we had temperatures down to -10 degrees Celsius, especially last January. Um, they were, which are outside of our design temperature of -7 degrees. So we were up to -10, not including wind chill. So it was very cold for Vancouver. I know the rest of Canada was probably like, oh no, that's not that cold, but it was very cold for us. We had snow, our highways were shut down. So outside air temperature, we saw no drop off in efficiencies. And when we looked more into this, what we found is that the robo units can operate down to -30, I believe it is, -30 degrees Celsius. And at that point, they just operate similar to a condensing boiler. So they'd have efficiencies about 0.95% or 95%. Next up is our backup or peaking boiler. So like I said, the existing boilers were used just to save cost and time, but they were rated at 80%. But we found they were operating, when we did more analysis, we found they were operating between 59 and 80%. And when we use these as a backup or a peaking boiler, the efficiencies dropped further down to 30 to 40%, because these boilers were short cycling. Just to top up that 1, 2 degrees or 5 degrees, whatever it was, it really caused efficiencies to drop a lot. So in the future, what we found out is that we could avoid that short cycling by adding modulating condensing tankless boilers for peaking instead of the poor existing boilers. And last month, for one of the sites as well, we did install condensing boilers. We removed the existing boilers, and we added tankless boilers, and with a turn down ratio of 11 to 1. So we anticipate higher savings and higher GE and COPs as well. So we'll have results on that later this year as well. Next is dynamic control. So when we decided with this pilot, we decided to use the Rover DDC system, and the DDC system just controls the Rover units. A lot of the feedback we got is it's really important to use dynamic controls, tie it into your building automation system or your building DDC system. This will help sequence operation and flow through the gap units and increase efficiencies as well. But for our pilot, a lot of the buildings that we looked at were older. They did not have BAS system or DDC system. That's something important to keep in mind as well. Next is contractor feedback. So initial perception showed some concern with the installation procedures and ammonia of the gap unit. So these gas absorption heat pump uses ammonia water solution, and it uses about 14 pounds of ammonia mixture. So a couple of years ago, we had an ammonia leak here in BC at an ice rink in northern BC, actually, which resulted in fatalities. And that was due to hundreds of pounds of ammonia that leaked. So because of that, a lot of the contractors were wary about this technology, as well as some of their customers, especially the school districts, because they didn't want to have an accident similar. Obviously, we didn't either as well. But once we told them it's 14 pounds of water mixture, it's just not straight of 14 pounds of ammonia, it's ammonia and a water mixture, as well as these units being outside. They were put at ease. And our the manufacturer Rober was great at providing documents for this. So shout out to Rober. They did put everyone's mind at ease. For our final evaluation, now after our installation and pilot, we asked the contractors what they felt. We sent out surveys to them. So 7 contractors responded that they're satisfied with the units and would recommend installing these in the future, especially to other clients. 5 of the 7 contractors say they foresee the cost and time to install the units decreasing in the future. And majority of the contractors say that these were easy installations and no different than installing condensing boilers. Initially, when we started talking about these, they thought it's like a black box. They thought it'd require a lot of engineering, a lot of feedback. But once they got their hands on it and started working with the units, they were like, oh, this is very similar to installing condensing boilers. So very happy with the contractor feedback as well. So that's our findings in a nutshell. I'll pass it back to Mila.
Awesome. So just to summarize kind of next steps, we are going to be busy. We've got a commercial space heating pilot that we've launched this year. And so we're excited to kind of prove out the performance in space heating, which we know is a more consistent load rather than domestic hot water. So we're excited to see how the efficiencies can even grow in that end use, as well as we're launching and installing a residential gas heat pump combi unit prototype from Thermolift. So we're really excited. We've got 10 participants, residential participants, lined up to install this later this year. So we'll be measuring that for 1 year for both space and water heating applications. And then lastly, FortisBC is developing a small introductory rebate offer this year for commercial gas heat pumps. And we're going to be targeting about 20 installations. So really we're just kicking it off to see how the market's going to react with this introductory offer. And then last slide, please, Rob. Awesome. So in summary, we've identified that natural gas heat pumps, the one we tested at least, can perform over 100% efficiencies. We had high customer acceptance. We didn't see any installation challenges, and we were very excited to move forward with an introductory rebate offer. We know that these gas heat pumps are going to play a critical role in reducing future residential and commercial emissions, especially for our natural gas customers. But we recognize it takes a village to drive the adoption and awareness of a new technology category. And we're just one of many passionate players in this space that are, there's just so many people across Canada, you guys, that are doing such great work evaluating gas heat pumps. So it's just really great to see that. And in closing, if you're ever interested in joining working groups or industry collaboration opportunities, there's the newly formed North American Gas Heat Pump Collaborative, as well as Natural Resources Canada has a gas heat pump working group. So my hope is that if you're interested in any collaboration opportunities, that you please reach out to myself and Rav. Our contact information is up on the slide. And thank you so much. I'm really excited to get to some questions.
Awesome. Thank you both for your presentation on an overview of what natural gas heat pumps are and also a look at how they are working. And so thank you again for that. So just a reminder, there are 2 ways to ask questions. You can raise your hand and I can unmute you and you can ask yourself, or I see there's a lot of questions already here in the Q&A. I know there's a few questions in the chat, but just a reminder for people to please put them in the question and answer. It's much easier for me to get through them all if I can see them, because there's some in the chat. People are chatting as well as asking questions. So the first question here I'm going to ask, I did answer one about renewable natural gas, but actually we had Enbridge come on and do a whole presentation about renewable natural gas. So I did add a link to that. So I'm going to save you guys for answering that question, because we'll focus on natural gas heat pumps as well. So people had some questions directly into Fortis here, so which I think hopefully you guys will be able to answer. So there's the first question is there a code/standard that is applicable for this technology in Canada yet?
Yep, I'll take that. So for the gas absorption heat pump, we have the ANSI Z21.40.1, 0.2, and 0.4. So those are the codes that apply here.
Perfect. So good answer. And another question actually here from Patrick is, what's the service network like right now in Canada? I don't know if you know Canada, you might just have the BC context, in the event of a breakdown.
So we're not sure about the rest of Canada. I know in BC we do have a local especially for Rober, we do have a local distributor. They do keep parts on hand. We did have a failure on one of the pieces, and I forgot what it was. I think it was the
Like a
control
fan.
board. Yeah, fan and the control board, and it was up and running within a week. They had everything on site. The contractor went out, just replaced it, plug and play, and we were all good to go.
And just to add, I think by doing the pilot demonstration, they were able to set up a local distributor to support our installs and our contractors. So without doing that and having a pilot program, then that would have been something we would be lacking to support a future program. But now that we have that all lined up, it helps us start to add incentives much easier now.
Perfect. And there's actually a question here because I know some people are homeowners and they're not in the energy efficiency sector, so they don't know the intricacies. But especially in BC, especially with FortisBC, because you guys run programs for natural gas and electrical for heat pumps. So Zane is actually wondering, I'll ask her question. As a homeowner, I'm confused, which we can all understand. Fortis offers great rebates for electrically powered heat pumps. This encourages people to buy electrical heat pumps. So in a few years, Fortis, are they going to encourage people to purchase natural gas heat pumps? You can understand why people are reluctant to invest. Can you guys touch on this and just like clear this up for homeowners?
Yeah,
Yeah.
absolutely. So we live in the world of demand side management. And so we're all about energy efficiency. And we really look at what your baseline fuel source is. So for all of our electric customers that have baseline electric fuels energy, we offer them these amazing new technologies to get energy savings, such as electric heat pumps. Right now, for our natural gas customers, there aren't any residential gas heat pumps available. But in the future, our hopes is to be able to drive the adoption for our residential customers and offer incentives for them to also be able to get more energy savings and reduce emissions for their home or business. So yes, we're technology agnostic. Heat pump category in general is amazing, and we really see that it's going to be the future for energy efficiency.
And just to add, for electric customers, where we do offer electric heat pump rebates, that's only in the interior Okanagan, our shared service territory. Because I know in Vancouver, we're just strictly gas. BC Hydro takes care of that electric heat pumps here, but in our shared path, that's definitely true.
Perfect. Thank you. Yeah. When you just see FortisBC, sometimes it's a little, or FortisBC. Yeah. It's a little confusing for customers.
Yeah.
So I get it.
Mhm.
I'm sure you guys get it all the time too. Actually, just kind of on that note, Mohammed is asking, what's Fortis's path and strategy to getting to zero emission power generation?
Rob, would you like to take this one, or do you want me to take a stab?
You could take a stab, and then I'll just add in.
Well, we do very much so. We have a diversified pathway approach to reaching our federal and provincial emission targets. It is published on our website, but what we're focusing on today and what Rav and I are here to present is just one of the many pathways and strategies to reducing emissions. And that's through the investigation and advancement of gas heat pump technology on natural gas side. So that would be a question, unfortunately, that somebody else from an internal department, that's their blood, sweat, and tears they focus on. But if you want to connect with me, I'd be happy to get you in touch with somebody offline to.
And I could also add, we are looking, like Mila mentioned, renewable natural gas. We have a lot coming online in the next few years. We do offer some as well right now, as well as we're looking at hydrogen injection as well into our pipelines as well. So there's a lot going on behind the scenes. Yes, that is a bit outside of our departments. So yeah, but Mohammed, happy to touch base offline.
And both of your emails are up on the screen as well as phone numbers. You guys are brave.
Hey, it's a good thing.
But if anyone can't see it, they can also reach out to Efficiency Canada. We're also happy to connect with either Mila or Rev or anyone else on the FortisBC team as well. And I will say that I do applaud FortisBC for having an aggressive energy efficiency strategy, because that's not always the case with every utility in Canada. So, thank you for doing that. It is a good thing, and you guys are thinking about it, which is nice to see as well. So a question here from David is, what about gas absorption for cooling to lower peak demand?
So I'll take that, Mila. So with our BC UC or BC Utility Commission, we can't offer anything about cooling, any rebates for cooling. So we don't usually investigate the cooling side of it. But what I've seen in the past is like, yeah, people have used gas absorption cooling as well to reduce their peak demand. But it's just that we don't provide rebates on that for our part. Yeah.
A question here from Terry is there a consideration beyond the natural gas heat pump, looking at the extraction side? The cost of electricity makes a natural gas attractive now. When the electricity energy comes as an effect, then what?
So yeah, we're always looking for new technologies or anything. So anything that could help. We're not placing all our bets on natural gas heat pumps to solve our problems in the world, but we're always looking anything that could help to get that extraction or help wherever we can. Like at the our end goal is to help the customers make decisions themselves. It's not that we're pushing natural gas, we're pushing electric heat pumps. We're here to help the customers decide for themselves, be like, what makes the most financial sense for them. So we're here to help whichever pathway we go down.
Providing options.
Hmm.
A question here from Thomas is, you mentioned a report that you're working on or might have finished. Will FortisBC publish the findings in the report and make it available to the public or to the industry?
We don't publish our evaluation reports publicly, but hopefully Natalie can have us back when our evaluation results are in, and we'd be happy to share with you all on this forum.
Yeah, that would be great, because a lot of people are interested, especially from the sector, and just finding the results out. So that's great. And the question and answer period is always, sometimes there's some hard questions there, but people are free to ask, because I'm sure it's on a lot of people's minds.
And just to add, like in the future, we may have like best practices as well in the future, especially with the pilots that are completing this year as well. Start helping the industry as well move forward. So eventually, I think we might have something available.
Perfect. And, stay tuned for a Friday discovery session in the future. A question here, just a clarification question, is can you elaborate on the residential pilot that took place in 2020 for 2,000 residential customers? So were these new build or multi-residential building, or can you just clarify the type of residential building?
So we've recruited over 2,000 customers that said that they're interested in piloting innovative technologies to reduce natural gas. And it could be a variety of different technologies. So we have a nice pool of participants. From those 2,000, we were able to select 10 residential customers that are going to be installing a new prototype combi gas heat pump in their home. It's called Thermalift. It can do space heating, domestic hot water, and cooling, but because we're in the demand side management world, we're going to be measuring it for space heating and hot water. So we're really excited with that technology, because we see that for this thermal compression type of gas heat pump, that efficiencies can get upwards to 1.5, 1.6. So we're going to be installing prototypes later this year and evaluating those the performance in field for 1 year.
Awesome. It should be exciting. We'll have to have you back for that as well.
We'll be back in a year again.
Exactly. A question here from Sherry is, what's the rate of fugitive emissions on natural gas heat pumps? I think Sherry's in Alberta because she said that this could be a great way to get Alberta going on heat pumps so that they can keep the fugitive emissions to a minimum, and it's functional to -30. That's awesome.
We actually have colleagues in Alberta and ATCO that are investigating gas heat pumps, and through the Natural Gas Innovation Fund, I believe that there'll be an upcoming pilot for residential gas heat pumps in Alberta, so which is very, very promising. And what we know that they do work well in cold climates, but a lot of these gas heat pumps will be able in the future to run off renewable natural gas and hydrogen, which is even better for reducing emissions and meeting our climate action target goals. So it's coming, and we're trialing and evaluating. So step by step at a time, we'll get there.
That's what pilots are key to make sure it works before expanding it to everyone.
Yes.
Yeah, definitely. A question here from Daniel is, are the gas heat pumps compatible with propane as a fuel source for consideration in remote applications without grid hookup for gas or even electricity?
So it depends on what type it is and who the manufacturer is. I believe some of them are available. That I think there's a little internal changes that they could do for you in the factory, but I'm not sure. That'd be up to the manufacturer.
Perfect. And I noticed that Alpha did comment on it and said, yes, they also work on propane.
Oh, okay.
So there must be some that do.
Yeah, and I'm sure it should be compatible. Yeah.
Perfect. I'm just going to get to one more question here, just because we're running out of time. People are very interested in this topic. So how can designers decide if it makes sense for them to install a GHP in a commercial site, and how to size the system? I don't know if that's a quick answer.
Yeah.
It depends.
It depends on your building size, your load profile of the building as well, and especially if you're doing space heating, if you're doing domestic hot water side, what their temperature loop is for their hydronic heating. So yeah, it's pretty complicated, but we could talk about that offline as well if you need.
Perfect. You guys are going to have a busy day.
Yeah.
Your day's booked for the rest of the day, I think. So thank you again to Mila and Rob for joining us today and sharing your presentation on natural gas heat pumps and answering some of those questions for us. I'm sure, and answering the future questions that you guys are about to get on your calls that you guys are going to get. And just a reminder to people that if you haven't already signed on to our support the funding of the upcoming federal budget, we're asking to support funding for low-income energy efficiency programs. I know FortisBC has signed on. You can find details under our Take Action tab on our website. So thank you to FortisBC and the over 100 other organizations that have already signed on in support. So again, this is our ask to the federal government, who's coming out with budget 2021, and we're asking for a chunk of change to go to the support for low-income energy efficiency programs. And so again, join us for next Friday as our guest Nicholas Gall, Director of Distributed Energy Resources at the Canadian Renewable Energy Association, is going to share how rooftop solar can play a key role in enabling the decarbonization of transportation, heat, and industrial processes. So another great session. Again, thanks again today, and have a great Friday and a wonderful weekend. Thanks, everyone. Bye.